Hello everyone, welcome to Electricity Power Outage Analysis in Tamil Nadu, India. It's undertaken by Omdana Chennai, India chapter. Power is one of the most critical components of infrastructure crucial for the economic growth and welfare of nations. Sustained economic growth continues to derive electricity demand in India. Consumption of electricity is known to follow economic activity very closely. We have seen recently that lot of power cuts and voltage drop issues in many residential areas of Tamil Nadu. So we wanted to know what is causing the mismatch between the demand versus supply. And also we have derived a lot of information about the power outage duration and their related locations. Our project timeline goes like this: from the data collection to visualization. It was almost 6 weeks time, and we have divided the data collection into 3 main tasks. We have collected the power plant details like its capacity, actual generation, the latitude and longitude details, type of the power plant from Google Earth Engine dataset. We extracted the demand supply data, related consumption of consumers from government portals. We extracted details of the power outage from websites where the scheduled outage has been declared well in advance. We have used different types of models: LSTM, ARIMA, SERIMAX, also some XGBoost like regressor models to understand the pattern. Hydro net generation has seen an increase from 2017, whereas the gas and thermal net generation has seen a decline since 2014, and windmill solar supplied only in the year 2018. Also, if we see the consumer versus category, the commercial consumption was the second highest next to domestic consumption. There was a steady increase from 2012 to 2022 in the demand versus supply curve. Both were converging. From our EDA, we understood the power demand has seen increase with the time. We have deployed different type of models. The XGBoost regression we tried. Though it is powerful, it did not converge well with our dataset. So we tried other models like ARIMA or SERIMAX, where we try to decompose the data into trend, seasonality and residual. Data was very much stationary and the outliers were almost null after the year of 2016. So at the end we came to a conclusion that in another 1 year's time, for the next forthcoming year, there is no much change in the outage. So this is going to be constant for the next 1 year. We had used Tableau to plot the power plant details and the source-wise detail of each and every power plant with the capacity and the type. And also we plotted the net generation of each and every type of power plants. Whichever data was available, we just used it. If you see, the gas power plant net generation has been steadily decreasing, and in 2022 this is almost 1097 MU. And also we plotted the load shedding details. We took the coordinate points of each and every area in which the outage happened, and we plotted those details in the map. And if you see, the outage details varies from place to place. In some places it is more than 5 hours, and some places it is 4 hours, some places it is 6 hours, something like that. And if you see the capacity of the power plants, it is varying from the year 2002 till 2022, and the consumption of the category is also varying year by year. This is the overall consumption of all the category of consumers. For example, if we see for 2016, the consumption, the industries were on the top. The next is the domestic consumers. This is the demand and supply year-wise details. So we could see the demand is steadily increasing. So collaborators who have contributed in the project, we have come to the end of this presentation. Thank you very much.